Off.
All right, okay. We're just showing off really at the moment. This is the kit we've been streaming with today. So this is the video end. So we sat here with the club mixer, which is cutting between the 4 video sources that it will cut between, which has been 3 cameras and the overhead projector that you've probably seen pictures from. Q-Box, which is a home-built piece of kit that I put together in the last few weeks, but that turns the red lights on the cameras that are on air. That's an innovation this time. We've never had a Q-Box that's shown. It's got call buttons on it, so I can call any individual camera by pressing the buttons. It's lit up and working, sometimes I haven't unplugged it, but I can call any individual camera, and we can also talk to the cameras. So I've got a little computer headset here. I can put that on and I can talk to the cameras. So that's part of the streaming kit. Very inexpensive streaming part of the kit is this little slide store here, which is where you've been seeing the captions come from. So it is about a £15–20 item, and it was meant for putting old stills camera pictures onto your television set. So I'm not sure whether they're still around now, but you can take the little SD card out of it. I can put it into the computer. I can generate computer graphics, just a bit of Photoshop or any simple graphics program, and then I can call them up with a handset here. Okay. It's using my 5th source, and I've only got 4 inputs to the mixer. So what we tend to do is keep swapping plugs around. We will sort that out. Down by my feet, if we can get to it, is the new club computer. What we're going to do is all this kit that you can see on the table that we constantly wire up at every event is going to go into this case. So we just take the case to an event, plug it in, plug the internet in, and plug the cameras in, and away we go. Rather than all the spaghetti that you can probably see around on the table that's been dived into 2 or 3 times over the last 24 hours to make it work. The computer screen is not an ideal one. I think it's a 1440, and I had visions of 4 bits of software coming up in a quadrature, so you could see the streamer output, the Adobe encoder, and probably see other bits on the screen. Unfortunately, it's not been that successful. So I think we need to invest in a slightly higher resolution screen, but we've managed. We've got through the day. So we can actually see the video has been recorded on the big computer that I've just shown you. I can see that it's been recorded on here. And if I go to the software, let me just, I don't want to get pictures of the software, but if I go to that one, that's a video recorder. So that's a piece of black magic, and it really is magic. We've got a video card in the machine and a big red button. You press record. As you can see, we get an audio as well from me, and that's recording everything at this event onto a hard drive at a high resolution, much higher resolution than the streaming resolution. So we've got a permanent copy. They will come off the hard drive eventually, but previously we've been using a video recorder with tape. This time, one computer. The one computer is doing the streaming and doing the recordings, and it's got something like half a terabyte in there. It's been running most of the day. That's yours truly. Ready for my close-up, Mr. DeMills? Let me pass the mic on to Peter, who's going to go around and show you other things other than this streaming jumble.
I've only got one thing to say. I think with a bit more training, he could be an artist, couldn't he? You know, we'll work at it. Okay.
Thank you very much indeed.
Right, next item we've got is someone who we're extremely grateful to. And if you come here, this is Charles. If you like to hang on to that, Charles.
Yeah, hello
Charles,
there.
Charles has very kindly helped us with the satellite dish, and he's going to do a couple of minutes on the modem down here, and then you'll see the dish outside. And this is the feed you're watching.
Okay. Well, one of the problems with streaming via the internet, especially if you're holding a conference such as in a hotel, is that you're sharing the internet connection with n number of users. And about 2 years ago, I got involved with streaming a folk festival, and that was from...
Okay, let me just fill in for a little bit. We've lost the camera, and we're working on it. Our engineers are working very hard. It's a completely mobile system, and I'm told we're back again. Right, let me just hand you back over to Peter.
I think it's a much more domestic problem. I think we've left a tape in the camera, and it's timing out. So, Charles, there we are. Once again, finish off.
Right, part 2. So about 2 years ago, I was asked to stream a folk festival, and from a greenfield site, and it was going to cost a vast fortune to have BT lines dragged over a 60-acre site. So after a lot of research, discovered that we could actually do the link via satellite, and the satellite dish I used for that event, and also for the year after, I've brought to the conference today. The dish itself, if we can just go outside, the dish is a 1.2 metre dish, and it's going up to the UTEL-2 satellite at the moment, which is about 23.6 degrees above the horizon. In fact, it's positioned above North Africa, and the LMB is producing about 2 watts of RF into approximately a 40 dB dish. In fact, it's on 11.585 is the transponder we're using. I keep the dish active through the year on a very low grader service, but for today I've got the providers to turn the thing on to give us some decent bandwidth, which is uncontested. So today we're not sharing bandwidth with anyone, it's straight up to the satellite and back down again. The endpoint is in Germany, and from Germany we're going via the net over to the streaming providers which are in the Docklands. The far end of the dish cable goes to a satellite modem. Hi Heather, the XY I was watching at home, so I'm not uptown in a pub somewhere. Here we go. So here we go, and there's the Hughes modem, satellite modem, and you can see the lights twinkling away at the moment, and those are the packets going up onto the dish. And we've got about half a meg bandwidth up and 1 meg coming down. And if you look at the screen here, our signal strength at the moment is about 87, which is quite a good signal, and we're not losing any packets at all. The alignment of the dish is really critical, and a fraction of a degree can knock us off the satellite, so we have to be very careful with that, not to disturb other users. And on the bench here we've got the spectrum analyzer, which is looking at the transponder we're using. And if I can find a pointing tool, that tiny little blip there around 11.585 in fact is our bit of the satellite, and say alignment is quite critical. And then the whole thing comes out of the modem into a domestic hub, and my laptop is for general monitoring, and the connection then goes to the video streamer, and that's it about it. Costs of running this thing are fairly horrific, around about £140 for the day, but we've persuaded somebody else to pay for that. It's a testing day. So it's been a real privilege to be invited to bring the dish to the conference, and it's been of service.
Charles, thank you very much for your help. Much appreciated. Pleased you made contact with us, and you've helped us enormously today. Right, next one is Mike Cox. Come and have a look at Mike Cox's unit. Mike Cox? So this is Mike's camera, but I think he'll come and explain. So, right. Okay. So here's if you come around with the camera, now. So here's a familiar face, Mike Cox, and he's more than capable of presenting himself. So here's the microphone.
Oh right.
I might ask you a few questions if that's okay.
Yes, indeed.
So
yes.
what have we got here?
Well, I've got a crude demonstration of 3D technology. Very crude. I suppose you ought to start with the camera, don't you, around the corner? Without a camera, of course, we don't really have much in, it's got a proper some 3D source. Hence the 2 Sony cameras mounted on a rather solid block to keep them sort of together. The signal comes down the cable, and we go back into the Are we in trouble?
Just 1 second, we think we've lost audio.
It's always sound's problem, of course. Right, well, from the camera cable, we've got a control unit, which takes in the camera videos, a couple of synchronizers, here and here, which makes the 2 camera signals, which are totally wild as beforehand, synchronous, so we can switch between them at field rate and produce a display on the Sony monitor here. But we have to look at it through the shuttered glasses in order to get the 3D effect, because it switches right, left at field rate. And so there we go. But of course no system is complete without the means of recording, so because it's 625 field sequential, we can record it on a perfectly ordinary DV recorder. We can play it back on this CRT display and look at it through the shuttered glasses, and you'll get the 3D effect. Unhappily, to drive the two projectors.
So what here? We've got like a little theatre for the demo.
That's right. And I'm wearing 3D spectacles, so I see a rather nice 3D picture on the screen there of people various around the streaming desk. But
and the projectors?
The projectors are a couple of Acer projectors mounted on what I'm pleased to call a projector cage.
Wonderful structure.
To keep, all made out of the finest marine ply and chipboard, with post office rubber bands for tensioning, because you have to adjust the relative angles of the two projectors in order to get them congruent, the pictures congruent on the screen.
Where are the polarizing filters then?
The polarizing filters in front of the lens on these little mounts here, and one is a genuine circular polarizing filter as bought from an optical supplier. The other is cut from one of these pairs of spectacles. The other one was, but for some reason I mounted them too close to the lens and it actually burnt a hole in it.
Ah, practical problem.
Practical problem, absolutely. So, and the final practical problem, I think it's worth mentioning, is because it's circular polarized on the projectors, you have to have a silver screen which reflects the light without distorting the polarizing effect. You cannot project it onto the wall and get the right effect. It's a sad thing, because these spectacles are cheap as chips.
Yes.
Silver screens are probably a bit more expensive. But there we go.
This is a special surface then?
Yeah, I think it's aluminized, actually. Right. It's used for proper projection in presentations and that sort of thing. Right. And I happen to be lucky enough to win a damaged screen, and I just cut a bit off it.
Great. Well, thank you very much for spending all the time and bringing it to show us. We appreciate it.
Okay. All right. Thank you.
I'm going to find Ian now, KKD, and he's going to tell us a little bit.
He's waiting for us.
Ah. Ian, would you like to... what we've got here is some equipment that Ian mentioned earlier, but I'll let him bring it. It's could you do us a couple of minutes on what you got here, Ian?
Yes, well, it's a 200 to 300 watt, 70 centimetre DATV transmitter, which I'm in process of building, but it's not quite complete yet, in that the final PA is not finished.
Well, that's a big PA. What does that run?
That will run up to 300 watts, but preferably only to 200. The system comprises the first unit, which accepts 1249 meg QPSK,
yes,
which is pre-existing and used to feed into our local repeater, and that mixes it with a local oscillator to bring it down to 436 megs, passes through a filter, yes, and a variable attenuator, which gives plus or minus a total of 10 dBs drive adjustment, through an amplifier, and then into the first of these modules.
And what power level is that then?
This is this kit of 3 modules were manufactured by Continental Microwave, and this one is a linear Class A amplifier, which when driven with half a milliwatt, will produce up to 30 watts QPSK with very good spectral regrowth. In fact, it's so low it's really down in the noise.
That's almost, that you take it almost straight out.
Well, you can.
I think so. Yeah.
In fact, and that's in fact what I'm doing here. That feeds through a couple of directional couplers, up and down couplers. The up coupler just gives a power indication. The down coupler gives a power indication which can be switched forward, reverse.
Very good.
And also feeds a signal into a comparator, which is set such that if the reflected power gets up to 2.5 watts, it trips the supply to the and has to be reset and get a red indication of VSWR. And then, when it's all complete, this connection here will be transferred to the PA. and the connection will then be taken back from PA to the output coupler, and that will give 200 watts, I am told. I haven't this with response purity, or up to 300 watts with not so good.
Excellent.
And the whole thing's driven by a switch mode power supply, which 28 volts, capable of 100 amps, but only being used for 30 amps.
Right.
And
BATC, and this in fact was one of my exhibits to start the machine going.
It was meant to demonstrate both 10 gigahertz and 70 centimeters narrowband to 2 megasymbols. On the right hand side here, well, this is the common coder, and I've got it feeding two systems, one going this way to 10G. We're replaying a CD at the moment. You can see here's the low-cost domestic receivers running, they're all running 2 megasymbol. And I have a little simple antenna mechanism at the back of the unit, so it's all running quite low power because we're all in a short distance. Over on this side, I've got a 70 meg to 437 transmitter, and again into one of the receivers here, and they give you a rather nice information page. You can see here, look, fiddle strength and also the bit error rate, and we've got a series of attenuators to drop the level to the point where it'll fail to demonstrate the threshold. Oh, I'm going the wrong way. Oh well, anyway, you can will freeze in the end. There you are, it's beginning to freeze now. Okay, it's frozen picture there now. Take the info page off, and you can see these are 2 megasymbol pictures here. A couple of other things is that the up converter that we're using on 77s is one of these little units from Zinwell, and this converts 70 centimeters.
I think everyone loves your pictures, but I think the sound's crap.
Okay. Okay, fine. So, demonstration of DATV at this end. I think that's all we're going to do for now. Thank you very much. Do you want to chop it then? So I'll just finish off. Thank you very much. I think we're going now to move on to our BGM, so we'll just fade from here now. Regards to everybody, wherever you are.